So this is a special case of the side splitter theorem. It's called the Midsegment Theorem. Alright, so I'm going to explain what you were doing in class a little bit, tell you what the Midsegment Theorem is, show you an example of the triangle, talk about how other ways that the Midsegment Theorem is used, show you one of those examples, point out the common mistake, and then let you summarize. Alright, so let's talk about what we did in class today. So on Friday we learned a little bit, we played with ratios, and then we practiced the side splitter theorem. So something that you should have learned today in class, maybe you didn't get a chance to, you should have noticed that we're going to use these part-to-part ratios here. And then this piece is a whole-to-whole ratio. So that starts playing around with what we did on Friday with the segment ratios. More specifically, what you should have found out is that if this is in like a ratio of like 2 to 3, then this piece here is going to be, this is going to be 2 to 5. So basically what we do is we take these two numbers over here, add them up to get the whole number at the bottom, and then this number stays the same. So if I want to talk about the ratio of those two, the whole-to-whole pieces, I'm going to take the part-to-part, add those two up. So 2 plus 3 is 5. And then I take that smaller ratio from the part and make it the ratio of DE, and the whole becomes the ratio, those two numbers added together. Little confusing, I know. So please make sure you ask me to go over it in class if you need to. But the midsegment theorem goes even more specific than that. So what we're saying with the midsegment theorem is that these two lines are parallel, and that these two pieces are equal. So these will be as well. Then this segment here, DE, the one we started with, is going to be half the length of the side it's parallel to. So using this diagram over here on the right, if DE is parallel to BC, and the ratio of AD to DB is 1 to 1, then DE is half of BC. So let's put this into practice. So this is actually kind of working backward. Well, no, it's not. So we have these two pieces. These are in a 1-to-1 ratio. So if they're in a 1-to-1 ratio, we have 1 to 1, this is part to part. I would add up 1 and 1 and I would get 2. And then I would take, so those add up together. And then I take the smaller ratio, or the top one, and I make it 1 to 2. So if this is 8 to 8, we could say this is 8 to the whole is 16. So 8 is half of 16, so x should be half of 6. So x equals 3. So going backwards, the converse is also true. If we know the segment is parallel, and we know that it's half of the one that it's parallel to, so you know, if this was 3 and this was 6, then we know that those two segments are going to be congruent, and these will be as well. Both going forwards and backwards through the theorem also works in trapezoids. So the trapezoid is that instead of this midsegment being half of this line, so add these markings in. NO is actually half of the sum of the two bases. So if this is 6 and this is 4, this line in the middle, NO, is going to be the average of those two. So it's going to be half of 6 plus 4. So it's going to be half of 10, which is 5. biggest mistake is forgetting to check if it's actually a midsegment. Like, so you might see the triangle set up, and you'll see, you know, maybe this is marked 12 down here, but this is marked, you know, this is marked 3, and this piece is marked 6. And so you didn't actually, if you don't actually check to make sure that these two pieces are congruent, then you might automatically assume that this is going to be a midsegment because, you know, we're going to be practicing this, and you might forget about the other just plain side splitter examples. So you remember to double check. If it's not a midsegment, we're going to need to set it up like 3 over 12 equals. And so then we would realize that x equals 3. All right, don't forget to summarize. You might want to jot down what the midsegment theorem is. Try to be really brief, like one good sentence about it. What makes the midsegment special from other side splitter examples, and what mistake or mistakes should you try to avoid.